built into our system. We've got detectors that can do it. So if there's something emitting ionizing radiation anywhere around, we'd be able to find it. I call that a sense, another kind of sense. Now, not only can we go outside of our five senses, we can vastly improve the five senses we have. And so what science is about, of course, is advancing our capacity to intersect with the cosmos. That's what science is. So that's what a microscope does. You see smaller things you never know. The telescope, see farther away. Particle accelerator. All of this are simply ways to enhance and extend and invent beyond our five senses. The simplest ones among these are, there's visible light, Roy G. Biv, right? You know Roy G. Biv, remember him? Red, orange, yellow, green, blue, indigo, violet. There's really only 6 colors there, but Isaac Newton, who first labeled these, he had a fascination with the number 7. And he came up with 6 colors. I got to put in a 7th one. And so he slipped in indigo there. Doesn't belong there at all, but he slipped it in. If you're going to put in indigo, you might have put in 7 other colors, have 14 colors in the spectrum. If you're going to be that specific. Indigo is this narrow segment between the blue and the violet. It doesn't, in that scheme, deserve its own color name, unless you're going to have way more than 7 to label. But that's neither here nor there. So those are the colors, and we define that as visible light, but light goes far beyond each side of that spectrum. You go beyond violet, you get ultraviolet. You go the other side of red, you get infrared. And you keep going in each direction, so violet, ultraviolet, X-rays, gamma rays. Red, infrared, microwaves, radio waves. All of this is light. It all travels at the speed of light, and we had no telescopes capable of observing outside of the visible spectrum until 1920, and that was a very crude telescope itself. And we didn't start really getting data on this until the 1950s and 60s. So we were practically blind to the universe before 50 years ago, thinking that our eyes were somehow the true measure of what's out there. So all of our detectors and telescopes were extensions of our eyes and not probes into whole other branches of what we call the electromagnetic spectrum. And so your senses are really these, they're good for, getting around the house, but they're not good for decoding the universe. And here's how they get in the way. There's something called common sense, right? What is common sense? Common sense is, if I let go of this gavel, it will drop. So let's try that. Okay, it dropped. Now, so important is that fact to our senses that when you tell me to drop it, that's an instruction for me to let go of it. What you really should be telling me to do is let go. That's your instructions to me. Then it drops. Okay? Suppose we lived in a world where 30% of the time I let go, this would float up to the ceiling. Then you wouldn't say, just drop it. You just say, let go. And 30% of the time, it would go up. Now, it sounds like I'm just making this up to be funny, but no, there are parts of the universe for which the laws of physics as we experience them no longer apply. One of them, for example, is the branch of physics called quantum mechanics, where matter behaves in ways that defy common sense. Particles exist here, disappear out of existence, and pop into existence over here without any visible means of getting from here to there. A particle sits there, minds its own business, and then transforms into another particle of a whole completely different identity a split second later. This is matter behaving, not badly, matter behaving normally under those conditions. So, if I'm here and this cup of water disappears and shows up over here, we would say, that doesn't make sense. But if that's all you had known as a particle, you say, hey, that makes sense. So what you think makes sense has nothing to do with reality. It just has to do with your life experience. And your life experience may only be a small smidgen of reality, possibly even a distorted account of reality at that. So, what this means is, beginning in the 20th century, as our means of decoding nature became more and more and more powerful, we started realizing our common sense is no longer a tool to pass judgment on whether or not a scientific theory is correct. And thus was born quantum mechanics, relativity, curved space, expanding universe. So when I tell you that the entire universe has been around and expanding for 14 billion years, you go back 14 billion years ago, the entire universe fit on the head of a pin, you're going to say, that doesn't make sense. And I'm going to say, I don't care that it doesn't make sense. The universe doesn't care that it makes sense to you. That's not its goal in life, to make sense to you. It issues forth from a whole other investigation of the behavior of matter of the large, Einstein's general theory of relativity. And then there's this shotgun wedding of the general theory of relativity, the theory of the large, with quantum mechanics. This is the physics of the small. The early universe, the large was small. And there's general relativity and quantum mechanics intersecting in a shotgun marriage. They're not otherwise compatible descriptions of the universe. This works there and this works there. Now they got to work together. We have no understanding of how they'll work together. We got top people working on it. They're called string theorists, okay? And they're still not there yet. They're still not there. They're working on it. Every time I ask them, they say, oh, we're a couple of years away. They've been saying that for 20 years. I've been asking them since the early 80s. But it's the only game in town, and they're very inexpensive to support. You give them a pencil, you say, here you go, and some paper, and we'll throw in a computer, then they're done, okay? So I'm okay with that. They're not going to bankrupt the science budget. And so in the exposition of coming to your senses, it's basically a celebration of what it is to have 5 senses, but then the reality check on the fact that our senses are not only feeble, they're inadequate to properly decode all that's going on in the natural universe. And so a prevailing theme here is an attempt to give a reality check to the urge that we have, the urge, understandable, but inexcusable urge that we have to think more highly of ourselves than we actually deserve. This is a theme that's repeated through the history of human assessment of our place in the universe. And in a little ways, it continues that way today. But some are sort of have enough foresight and hindsight to say, oh, I'm not going to make that mistake again. Here we are on Earth, and Earth is special because it's Earth, and the rest of that's just the sky. And then we find out we're one of the planets. And then, oh, well, surely our sun is special. No, that's one of 100 billion other suns in our galaxy. Well, the Milky Way, yeah, that's the universe. No, Milky Way is one of 100 billion galaxies in the universe. Well, if we're in the galaxy, we must be in the center of the galaxy. No, we're out somewhere in Nowheresville, okay? Leading completely undistinguished existence in an undistinguished quadrant of an undistinguished galaxy. Get over it, okay? Find some other way to measure your importance in life. Don't reference the universe. Why not help someone? That'll measure your importance, okay? That's how to be important. Help somebody else lead a better life. And so that's a running theme, by the way. I say that there, but every one of these chapters, there's some reference to it. And so let me move on and pluck another one from the, how much time, damn, I ate up all the time just talking about that. I've got a chapter called Vagabonds of the Solar System. That one's fun. I'm not going to dwell on that too much because in there we talk about Pluto. Pluto, has been on hard times, Pluto. And and it's interesting because, I had a little something to do with that. In the year 2000, our exhibits at the American Museum of Natural History, I and 2 colleagues of mine were co-writers of all the exhibits. We decided, upon noticing that Pluto, there are other objects orbiting the sun about where Pluto orbits. About the same size as Pluto, made of the same stuff as Pluto, same cockamamie orbits like Pluto has. And so we said, well, let's organize the exhibit so Pluto is with the rest